Okay, hello everyone, this is Dr. Kao, welcome. Today we are going to go through one code about coronavirus data visualization and prediction. This code, they use the data from University of Johns Hopkins, and they provide the link here. So the cool thing of this code is you can actually run the code every day, and they are going to keep updated every day, so you can get the latest data and see the pattern. So the code, they import some of the library, including the pandas, which is a package I assign as a homework, as actual credits you could get if you do the pandas analysis. So you can definitely learn from this code. They also use sklearn for the modeling part, like linear regression, like the support vector machine. So you can also learn how to use the support vector machine in this code. So they start with pandas to read the CSV file from the link directly. So this is a link. The data will be updated every day. So make sure you rerun this code every day to get the latest data. You can print some of the data. For example, dot head will print a few lines of the data set. You will just see the province and the country, and also the data start from January 22nd till today, till recently. So today is 11th, but they get the data from yesterday. I think tomorrow you can get the data for today. Like the first one, Anhui is my hometown. So now let's go ahead and it's going to get the columns, and they are going to get all the data about the confirmed case, the number of deaths, and the recoveries. So this is pandas. You can use this function to get all the columns. I can just show you actually the confirmed. So if I can just run that for you, you can see the confirmed. They will get all the rows, and for the column, they will get the column 4 to the last column. So column 4 to the last column, which is here, from here, column 4 to the last column. Okay. So these are all the confirmed and deaths. Now you can actually calculate the some of the number, like you can get the confirmed sum, the word cases, like in the word, mortality rate, that would be the number of deaths divided by the confirmed case. So you can calculate the number, and the number is appended to the list. So it's day by day. This is day by day. And then you can also get the kind of format that into NumPy array. So now you can do the prediction. For example, you can predict for the future like 3 days. So this is just help you to prepare the data for the prediction. And then you can convert, here is the code, they convert the integer into the date time. So it's easier for the visualization. So you can take a look at the code. If you are wondering what is the result, you can always print. So just print the date, adjusted dates, okay? And then you can run the code. You can see the result. They call the method trans test split, which is a method we use at Node already, to split the training and the testing data. Obviously you can just print them and see what that looks like. So for example, I can print the X test confirmed, and then I can also print the Y test confirmed, right? So you can just print that. You see how it looks like. So this is X test for the testing dataset, and this is Y. Okay. Now we can take a look at the model. Like they use support vector machine. Support vector machine has several parameters. You can use linear kernel or RBF kernel. You can use change the C, gamma, and epsilon. They just try several numbers. You can definitely add more. So it will just explore different combination of these parameters and get the best of them. So you can run them, and it's going to train the support vector machine. So you provide the X train, Y train. Now you would just get the result. They can show you what is the best parameter. So this is the best parameter. It looks like the linear kernel is selected, and with this gamma and epsilon, you can just get some more information about the support vector machine. Here they printed out, they plot that. They plotted the support vector machine based testing, the prediction, and also the Y, the confirmed one. So you can see the pattern. And they also try to use a linear model, the linear regression, on the same training data set, and they make predictions on the testing. So for this linear regression, they calculate the mean absolute error and mean squared error, which is also similar like what we learned in the class, but they just call the function to do that. Now they print it out. You can see how your prediction versus a real Y, and the rest of them, they are going to just print different kind of figures, like to show you, like as the time goes, the number of cases confirmed, and also the prediction versus, like this is a SVM prediction versus the real number. And then they also talk about the as the different days and the number of confirmed using the linear regression model, and even the number of deaths. So you can see it's always increased. The mortality rate, you can see the rate is like basically decrease at the beginning and kind of increase. It's probably because some of the countries, they have very serious situations, so that's why it has a pattern. And the cases recovered is always increased, so which is good sign. This is a picture of the deaths and versus recoveries. Okay, deaths versus recoveries. They also get the data for each country, for the unique country. So this is the code they use, and then they print it out. You can see for different country and the number of cases by today. It's the same thing. They also analyze based on the province or state. So it's similar data, but basically they need the data based on the states. So you can see more states here. Of course, they didn't rank them. If you want, you can rank them. They filled out some NAs here in this code, and now they visualize this representation of different countries, different from outside of China and mainland China, also different this problem is different state, different state. Oh, sorry, this would be the this would be different countries still, and this would be different states. And then they also use the pie plot to plot with different countries, and this is another pie plot. They just draw based on different states. So overall, this would be the code is posted. You could always learn from the code. The in-class exercise I want you to do is I want you to explore different ways how they visualize the data, how they analyze the data, learn from the code, and try to use the code we learned in the class and do similar analysis. We learn the multiple regression or linear regression in the class, right? We have the code. So probably you could just apply the code we have, and see and compare the performance. If you like, you can also use sklearn. You can explore some other models. Just have fun. Like just try to use the things we learned in the class and do some modeling here. The second question, you don't really need to turn it in. The second question is we want you to explore some other resources. For example, the website called ENCODE 2019.live. So this is a website. They actually get the data from the Johns Hopkins dataset. So the website will just get the data and update every 10 minutes. They list all the countries. They also have the maps. They also have a wiki. So which is very interesting. And the most interesting thing is this website is just built by a student 17 years old. So a high school student. He spent his spare time and do this project, all managed by himself. So if you are interested, explore that. There is also GitHub. So you could explore the GitHub. They have all kinds of data and code here and how they visualize that. You probably can learn a lot from those. Okay, well, that's it for today's. Thank you very much, and enjoy this data analysis.